Hey, good morning, everybody, or good afternoon. I'm sorry the camera is refusing to work. I like to be on the screen for you guys to understand there is a real human being back here. Uh, Today's huge day, just an awesome day of shifting your focus. We will certainly do the traditional mathematics that we're used to, kind of like what you see on the screen right now, uh, with some algebra skills and angle addition segments and all that good stuff. But it all relies on you to kind of understand this. So what I want you to do first is stop the tape and actually write that one down. And in fact, today might be a really good one to have some really good notes. And we always start our notes with the date, and two-column proofs is what we're going to talk about today. Two-column proofs. So this is nothing more than a way to do a problem, but a very formal way. No, Mr. Sayers, I'm good. I don't have to be formal. Well, yeah, that's true. But if we want to do anything with it, if you want to make it a good, useful tool, we all have to kind of see it the same way. And you'll find there's this puzzle involved every time. And it's a real good challenge. And once you get good at puzzles, there's nothing better. All right, so take your time to do this problem. Maybe you paused it, maybe you didn't. I'm going to go ahead and do it now. So we're going to do this crazy thing called the distributive property. So that is 2x plus 6 minus 5 is 5x plus 4. That is beautiful. I wish you could raise your hand and say, hey, Mr. Sayers made a mistake, because I certainly make them just like you. I'm going to combine like terms. I have a positive 6 and a negative 5. That makes positive 1. I'm going to subtract 2x from both sides. I'm going to subtract 4 from both sides. And I'm going to divide both sides by 3. Now I've got my answer. There is nothing at the end of today, if you can do that problem and just say those words, say them, but maybe write them down as I go, you have done what we call a two-column proof. You see how this is one column and this is going to be the second column. So what we have to do now is really focus in on what goes here. All right. So this is section 2.4, algebraic reasoning, and 2.5 is the two-column proof. So we don't say cuz, or that's the way it is, or you better believe me, stuff like that. I know that's on the playground and it usually works. In the court of law or the world of mathematics, we want to use kind of established justifications. And those are called properties of equality. Sure, that's a fancy way of saying addition, but that's all there is to it. Once again, please have your notes. I'm going to give you some that you're going to use a lot in tonight's homework. Looks like a lot, but it's just one good page that you want to have to reference. I know you'll have a test or a quiz, and I know at the end of the year we'll have this. So if you have this kind of a really nice notebook and you have 1 or 2 pages of these, then you can reference it. If you go to your book and you look at theorems and axioms and postulates, which is basically these justifications, there are thousands of them. Okay, so if you go on through mathematics, you don't memorize them, you just use them all the time. So it's no big deal. It's like, oh shoot, what am I going to use? If you go see a doctor, it's not like, oh shoot, that's the knee. Let's see, I better look it all up. No, they know it because they've used it. And just like mathematicians, you guys will have a very small subset. And so I'm giving you the first thing. This might be a nice thing to print off also. So this is what you're doing in your algebra. So maybe you add something to both sides. what you justify it with, what you say to the world, is you say addition. Well, that makes a lot of sense. And then if you want to get paid the big bucks, you add property of equality. Yeah, some of you, maybe the most I can get out of you is saying add or subtract. You know, I'll take it. I'm just saying there's your average grade. It's definitely passing. Awesome. But if you want to get that higher grade or that level of sophistication, you definitely want to throw in the property of equality. If you subtract, guess what? You're going to justify that with subtraction, property of equality, and so forth. So these are pretty much things that you've done 100 times, and you just now need to justify those steps right next to it. Maybe this is something that you can do, like, hey, Mr. Sayers, we just did that. But now we need to name that move, and that is this distributive property. Maybe you took 6 minus 5 and you wrote that as a positive 1. Well, all you did is combine like terms. We can say combine like terms. You can write combine like terms. That's sophisticated, but if you just write simplify, that certainly works too. Simplify can catch a lot of these moves. It's pretty nice. Substitute is really hard for me to say, well, when you substitute what? Well, that's the puzzle. That's the part. And I'm going to do an example here that shows you that move. All right. We're going to do our first 2-column proof. I'm telling you that we're probably going to use that, and that, and that somewhere in the proof. And you're like, Mr. Sayers, I just took all that time to write all that down, and you don't even have them. You have POE. POE, property of equality. Now, disclaimer, I had Miss Deal at Lincoln Junior High School, awesome geometry teacher. She made us write out every single word of every sentence on every proof. Okay, so for me to already shorten property of equality to POE, I bet she's kind of like twisting around a little bit. She's not enjoying that. So please take that as a vote of confidence in you that you don't. I believe you can do it, but let's include it. All right. So we just did this problem, but now we're going to do it again in the way of a 2-column proof. All right. So what is the first step of a first of all, 2 columns, obviously. You're going to draw this line. You're going to write the word justification on that. You're going to write the word statement on that. This can also be reason. Sometimes you'll see reason on that. So this is what we're used to. We're used to that side. We're used to just doing the math. All right, so nothing's going to change there. But over here is where we're going to write what is happening. Okay. All right. Well, the first step is to start with what's given. This is the problem. So guess what the first step is always? You always just rewrite the first what's stated. Hey, this is what we know. The key word here is given. Some people just fight proof and this is all they write. It's a start. It's definitely better than nothing, but come on. All right. So what was the first thing we did when we solved this? We took that 2 and we did that. So we got 2x plus 6 minus 5 equals 5x plus 4. And we asked ourselves, what did we do? What's that called? Oh, shoot, look at my notes. Oh, yeah, Mr. Sayers gave us that nice little example. This is called the distributive property. Nice. Next move we did was the 6 and the 5 were like terms, so we combined those. So we could say simplify or combine like terms. I like simplify. Here I subtracted 2x from both sides, and you can write it in there if you want. Most people at this stage are kind of like doing that in their head, but hey, if that's not you, that's fine. So that's going to cancel, so we're going to get 1 equals 3x plus 4, and that is the subtraction property of equality. As we go through this class, you'll see that I'll change the word equality to maybe congruence or segments, or it kind of has a lot to do what this symbol is right here. Just throwing that out. Hey, next thing I did was I subtracted 4 from both sides. So we got -3 is equal to 3x. And that would be subtraction. I'm going to write P-O-E, property of equality. Next thing I did was divide by 3. I got -1 equals x. And I say division property of equality. Now, in most worlds we're done, and most math books were done, I want to make sure that you give yourself, this is like it. When we talk about geometry, if you could start to formulate proofs that prove really cool things, people spend years of their life trying to prove things. There's this thing called Fermat's last theorem, written in the 1700s in the column of a book, and this guy Andrew Wiles back in the 80s decided that 1980s, 200 years later, that he was going to do this, and he spent 9 years of his life, and he finally got it. And you know, in our lifetime, that's probably the most impressive proof that people have been working on over and over and not gotten it. So it feels good when you're done. I choose a word. In some math books, you'll see Q-E-D at the end of a proof, and that is Latin for quo erratus demonstratus, and that basically means, hey, I did it. You'll also see just a little black box. That also signifies to the world, you have gotten what you've done. I've gotten x by itself. I'm good. I prefer BAM! Okay, that was something you'll never see in any math book, but to me, I'm psyched, I'm fired up. I got that word 25 years ago, and that's how I end all my proofs. So I give you full permission to pick a word that you want to write down. Anything that's, of course, school appropriate, just kind of fun, short, so you don't take a lot of time, and you know, makes you feel good. All right, we got 3 more things to add to your list of justifications, and these are going to come into it as we get better and better. I will tell you that this is the one that you're going to use 99% of the time compared to this and this. But what are they? Well, at any point you say a quantity equals a quantity, like 3 equals 3. Believe it or not, if you state that, you would justify it with the symmetric property. Oh, I'm sorry, these are switched. My bad. If you said 3 equals 3, then you would say, wow, that is a reflexive property. A symmetric property, if A equals B, and then the next sentence you write B equals A, that's when we say that is, oh, well, that's true because of the symmetric property. I guarantee you there's some eyes rolling. Don't even pretend that you weren't doing that. I get it. You're wondering why. It's so obvious, so simple. Oh man, it's so beautiful how everything falls together once you have a little experience with this. But I'm telling you, you're not going to really need this. We appreciate that you're pretty smart. You're not really going to need this, but the transitive property we're going to use all the time. So if you can show that maybe A equals B, great. And you know that B equals C. Then, and just look at that, common sense. If I ask you, what conclusion could you make if A equals B and B equals C? What's the only thing that maybe you could put those two together? Yeah. So if you have somewhere in your proof, in one of the statements, that this is true, and then later on you say this is true, and you justify it somehow, then you can state this, and you would write the transitive property of equality. Some people call it substitution because you're kind of, since B is equal to that, you're just kind of plugging it in for B, and that is that's acceptable. But if you want to get that top dollar, you're going to go for transitive property. All right, which POE illustrates? So if 6 equals 7, then I think I can say 7 equals 6, and that is the symmetric property. Now, of course, I wish we were doing this together. I give you time, you chime in, you've got your list, you're looking at it. There you go. How in the world could I justify to the world that 34 degrees equals 34 degrees? Would I have to? I know, but now we're starting to you're starting to get used to it. It's like, ooh, that's a door handle on a car. Well, yeah, but look how it works. Okay, all right. So, stay with me here. This is called the reflexive property. And I misspell this sometimes because the English interpretation. All right. Guess what? You're not going to believe this. The measure of angle 1 equals the measure of angle 2. We know that. But we know that angle 2 is equal to angle 5. Wow! We know that too. That's amazing. All right. Sorry. It says it's recording. Yep. All right. If 1 and 2 are equal and 2 and 5 are equal, what's the thing that we can combine? Since we have these, the 2's are combining it, then 1 and 5. Yay! So that is called the transitive property of equality. If JK equals KL, and we know that KL equals 16. So these are the two statements we know. We know this and this are true. How we put those together, we use our common sense, that could we now say JK is equal to 16? Absolutely. This looks a lot like transitive property, and if you write transitive property, I'm okay with it. Since this is kind of a numerical value, it leans towards substitution. But please understand that right in the beginning, the first couple of weeks of using this, those kind of go back and forth. Try to be open to when you see one over the other. All right, this is a homework problem. That's the only reason I'm doing this one. You're going to be asked to, in life you have to solve for, let's say I give you the area and the base and you need to find the height. You use this formula, but we need to justify those steps. So I would start out with area equals base height over 2 and just say, hey, that's given. My goal here is to get the b by itself. So I'm going to multiply both sides by 2. So I'm going to multiply that by 2 and that by 2. That's going to cross that 2 out. That's the reason I do it. Over here I get 2a equals bh, and that's multiplication. Property of equality. I'm going to divide both sides by h. Why? Because I want to get the b by itself. So I get 2a over h equals b. That is the division property of equality. Have I gotten what I needed? Yep, I am done. So I'm going to tell the world I have finished this problem. All right, another one off your homework. what are we given? We're given mx. That's not totally right. That's not written right. It should say mx equals 9, nothing over the top. So that's not really correct. And it should say xr equals 10. So that's not really right. Prove that mr equals 19. Okay. So I like to write in the picture. I like to write, they said this is 9, and they said this is 10, and they want me to prove that mr is equal to 19. I know. I'm telling you, we're using problems that are simple and easy in the statement side so you can kind of get used to the justification side. All right, the first thing you always do in any two-column proof is write your statements and justifications, and then you write down the given. So I'm going to write mx is equal to 9, and I'm going to say that's given. I'm going to say that xr equals 10, and that's given. Now, what do we know? We have this chapter that was a lot of common sense, but what did it say? It said that the little plus the little is equal to the big. So I can say that mx plus xr is equal to mr. Now, this is one of those things that, gee, I wish everybody just had the writing on the wall, but maybe you've forgotten that this actually has a name, and it's called the segment addition postulate. Right now, you may be seeing some depth perception here. You're like, whoa, this is getting a little, am I supposed to remember everything? Well, I would definitely lean forward. I would put this in the notes, so that next time you see a situation with a segment and you know pieces, maybe this is an important part. Well, do you know what mx is? Yep. Do you know what xr is? Yep. So we're going to substitute those in. 9 plus 10 equals mr. And we're going to say, hey, we substituted. Notice every step that I do here relies on the truth of what's above it. So every step is verified, 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 verified. Now I can work with this step right here and know that there's nothing wrong with it. I can do 9 plus 10 and I get 19 equals mr, and that is simplify, combining like terms. Have I gotten to what I wanted to do? Have I proved that mr equals 19? You bet. So this is where I tell the world I crushed it. If you want to be really cool, you do a little fill in the black box, or you can do QED. Quo erratus demonstratus. So just in case you're like, well, shoot, what else do I not know? These are the only two. This is the segment addition postulate. Whoa. I hit a little button on this pen, and I think it's an eraser too. So little plus little equals big. And remember, likewise, on angles, if I go little angle plus little angle, I get the big angle. Okay, and we're talking about the measurement or the opening. So this is called the angle addition postulate. Remember, the word postulate remains, hey, we're just going to accept this as truth. We don't have to prove this statement. So this is the justification for that statement, and likewise for the segment. So that's how you justify writing that little plus little equals big. Yeah, I don't like that problem. All right, last problem. This is number 4. You might notice a number 4 in your homework, so just throwing that out, that maybe I'm trying to help you out. Vocabulary is huge in this. The word complement is something that you should notice. And that's when two angles add up to 90 degrees. So you see how just kind of paying attention, they seem little things, but they're now going to start to add up. So if you don't remember what vertical angles are, or if they're equal or supplementary or complementary, those are the sort of things that you probably want to refresh your memory. All right, we're given three different angles. We know one is a complement of 2, so we know that kind of the measure of angle 1 plus the measure of angle 2 equals 90. So I'm just kind of scribbling over here because that's what I'm seeing in the given. Now this isn't part of the proof. It's just me trying to go, okay, what do I know? We know that 2 and 3 are equal. We know 2 and 3. Remember this symbol is congruent. Congruent means it's the same shape. It's the same shape. All right, I'm doing this one for a reason because there's some pretty obvious things to write, but we don't know that vocabulary yet. All right, the first step, they write 1 is a complement of 2, and they justify that because it was given. Look, it was given. They also say the angle 2 is congruent to angle 3. Well, guess what? That was also given. So that is what we're missing here. Now, 1 and 2 add up to 90 degrees. Isn't that what that means? So when you're using the definition of the word, that's all you have to write. Definition of complement. So it is vocabulary strong at this stage. You really need to see these words and understand what they mean mathematically so you can use them. All right, let's see what the rest of this proof looks like. So that was given, that was given, that was from, yep, we know that. The kind of 2 and 4 sure seem a lot alike. The subtle difference is they went from the shapes are the same to the measures are the same. And that is the definition of congruent angles. And that's what that symbol right here means, congruent. All right, so that's pretty cool. All right, now we know that 2 equals 3. We know that 1 plus 2 equals 90. So do you think, let's see, make sure what are we trying to prove here? We're trying to prove there's a relationship between 1 and 3. So when you're doing a proof, maybe we need to put 1 and 3 together. Is there a way for us to look at this statement and put 1 and 3 together? Well, you bet. The measure of angle 2 is equal to the measure of angle 3. That means I can just substitute it in. So I'm going to write measure of angle 1 plus the measure of angle 3 equals 90. And look at that. They already told me it's probably going to be substitution. If two angles add up to 90, the next statement I would write is they're complements of each other. That's the definition of complement angles. Ladies and gentlemen, welcome to your first day. We're going to have masters of this, and we're going to have people that kind of struggle with the T and drawing a straight line. I want everybody to be good at this. I have tons of patience. I know it took a little bit for today, but hopefully you can fast forward when you need to. There is your homework. These are a lot of one-word answers. Addition, property of equality, or multiplication. So I need you to give these a good shot. We just did number 4, but certainly would like you to go through and rewrite that and do that again, just to kind of go through that because it really holds your hands. Hey, good luck everybody. Appreciate your patience. Take care.